Okay, be honest. Imagine you have a choice between petting, say, a really silky golden retriever or maybe a Sphinx cat. One with no hair. Which one do you think is going to set off your allergies more?
The classic scenario. And yeah, most people would probably point to the fluffy dog.
And right. That's a tough ball. But, that's why we do this deep dive, isn't it? What feels right isn't always what the actual source material tells us.
Exactly. And our job today is to slice through those common ideas, pull out the really interesting bits, the practical stuff from our sources, get you informed, basically.
Quickly and thoroughly. So today's source material, it's all from the Consumers.App news aggregator.
Yep. Specifically, their Consumers 360 commentary dated June 8th, 2025. And it's quite a mix of consumer topics we're diving into.
Okay, let's dive right back into that pet allergy thing. The first headline we looked at from Consumers 360 was, Allergic to Your Pet. 7 myths about cat fur, dog dander, and hypoallergenic animals. That came originally from the South China Morning Post. So, back to the golden retriever versus the Sphinx cat. Is the hair really the issue?
Well, according to the Consumers Research Q&A on this, that's actually the number one myth, believing it's the animal hair itself. That's not quite right.
Wait, seriously, it's not the fur causing the sneezing and itching?
Not directly, no. The actual triggers, the things your immune system reacts to, are specific proteins. And you find those mainly in the animal's dander.
Dander. Those tiny skin flakes.
Exactly, microscopic skin flakes, but also in their saliva and, yes, even urine.
Okay, that is genuinely surprising. So the shedding, all that hair flying around, isn't the root cause? Maybe it just helps spread the allergens?
You've got it. The hair length or even how much they shed doesn't really change how much allergen the animal makes.
Right.
A long-haired cat produces allergens just like a short-haired one. The hair is more like a vehicle, gives the allergens something to cling to, helps them get spread around your house.
Which makes you immediately think about those so-called hypoallergenic pets, doesn't it?
It absolutely does. Consumers research basically confirms that the whole idea of a truly 100% hypoallergenic pet, that's another big myth.
No such thing.
Nope. All dogs, all cats, regardless of breed, they all produce these allergenic proteins.
Okay, but hang on. What about breeds like poodles or, those dogs marketed specifically as hypoallergenic because they don't shed much?
Ah, right. The thinking there is usually that if a breed sheds less fur, it might release less dander into the air. So potentially less spread of allergens.
Fewer allergens floating around, maybe?
Possibly. But, and this is key, it doesn't mean the animal produces fewer allergens overall. They're still making them. They're still in the saliva, still in the dander on their skin.
So getting a dog that doesn't shed isn't like a magic fix for allergies?
Not at all. And here's another important point from the research. Pet saliva. It's actually a major source of allergens. Yeah. When pets groom themselves, lick their fur, they're basically coating themselves in these allergen proteins from their saliva. For some people, that saliva protein is the main trigger, completely separate from hair or shedding.
Like a really crucial distinction. Okay, so if you are allergic, but you really, really want a pet, what can you actually do if hypoallergenic isn't the answer?
Well, the Q&A suggests focusing on managing the environment and the pet itself rather than chasing breed myths.
Like what?
Well, you could consider pets that naturally produce less dander to begin with, maybe reptiles or fish. For dogs and cats, it's all about minimizing the spread.
Meaning lots of cleaning.
Yep. Regular grooming, ideally by someone who isn't allergic, and really rigorous home cleaning. Think HEPA filter vacuums, washing pet beds often, that sort of thing. And critically, talk to an allergist. Get proper medical advice.
That makes sense. Manage the source and the environment. Oh, and there was this detail I found kind of wild. The allergens don't just stay in the house, right?
No, they're incredibly good travelers. These allergens easily stick to clothes, fabrics, furniture.
So you carry them around with you.
Exactly. You can take them to work, to school, into someone else's house, potentially triggering reactions in people, or even yourself miles away from the actual pet.
Wow. So someone could be having an allergic reaction in like the library because someone else walked in with cat dander on their coat?
It's entirely possible. It just shows how pervasive these microscopic things are. The research also touched on some wider science bits, like how early pet exposure might reduce risk, though that's complex, and studies confirming dog saliva is a big allergen source.
Okay, so for you listening, this really helps understand what's actually happening with pet allergies. It's about dander and saliva, not just fur length. And those allergens can travel. Focus on real management, not myths.
Understand the source, manage the problem. Exactly.
Okay, let's switch gears. Still thinking about sensitivities, but moving from pets to the plate. Our next headline from Consumers 360 is List of the 14 most common food allergens. This is from the European Food Information Council. Super relevant stuff.
Absolutely is. And the Consumers Research Q&A dives into this list. It covers the 14 allergens that are most recognized and regulated in the EU for, consumer safety.
And it includes the ones most people know, I assume, like peanuts, milk, eggs.
Yep, those are on there. Cereals with gluten, crustaceans, eggs, fish, peanuts, soybeans, milk, nuts. But it also includes some maybe less obvious ones.
Like what?
Things like celery, mustard, sesame seeds, sulfur dioxide and sulfites, lupin, and mollusks.
Okay, hold on. Sulfur dioxide, lupin, mollusks. What are those, quickly?
Right, good question. Sulfur dioxide and sulfites, those are often used as preservatives, especially in things like dried fruit or wine. Lupin is a type of legume, kind of like peanuts, used in some flours. And mollusks cover shellfish like mussels or clams. The point is they all contain proteins that can cause bad reactions in some people.
Gotcha. And this list is important because of labeling rules.
Exactly. EU Regulation 1169-011. It's a big deal for allergy sufferers. It mandates that these specific 14 allergens have to be clearly marked on food labels.
How clear is clear? Like tiny print?
No, much better than that. The rules say producers have to make the allergen info stand out. Usually means highlighting it in the ingredients list. Maybe bold text, different color, maybe just emphasizing it somehow.
Okay.
And what's really significant, the research points this out, it's not just for packaged food. This applies to food served in restaurants or cafes, too. That info has to be available.
That's huge for eating out safely.
Right.
What about symptoms? How do you know if you have a food allergy, and how do doctors figure it out?
Symptoms can really range. Mild stuff like hives, itching, maybe an upset stomach, all the way to severe, life-threatening anaphylaxis.
It's serious.
Very serious breathing problems, drop in blood pressure. Diagnosis usually starts with a detailed medical history, maybe trying an elimination diet. Then there are tests, skin prick tests, blood tests, or sometimes, under close medical watch, an oral food challenge.
And if you are diagnosed, what's the main strategy?
It really boils down to one thing: strict avoidance of that food. But just as important is being prepared for accidental exposure, carrying emergency meds like an epinephrine auto-injector if prescribed, maybe wearing medical alert jewelry, and just being super vigilant, reading every label every time, understanding cross-contamination risks, especially when eating out. Education is vital.
Are some people more likely to get food allergies?
Consumers research notes they're more common in kids, interestingly more in boys than girls. Family history plays a big role, and there's ongoing research looking at links to things like vitamin D, obesity, maybe even the hygiene hypothesis being too clean early on. But yeah, the general trend seems to be that they're increasing, especially in developed countries.
And that idea of early exposure, like with pets, does that apply to food too?
It's being explored, yeah. The Q&A mentions research suggesting that introducing certain allergenic foods early, carefully, and under medical guidance might help build tolerance, but definitely not something to DIY. The risks are too high.
Right. Okay, so for you listening, understanding this list, why labels matter, and the basics of managing food allergies, it's crucial, whether it affects you, someone you know, or even if you're just grocery shopping.
Absolutely essential knowledge for navigating food safely today.
All right, let's shift again. Moving to something broader. An external factor that's literally changing the air we breathe and, well, seemingly making allergies worse for many people. Next headline from Consumers 360, Climate Change is Worsening Seasonal Allergies. This one's from Counterpunch.
Yeah.
And it feels very current.
It is very current. And the Consumers research here draws a really clear line. Climate change is making pollen seasons longer and more intense in many places. It's not just a feeling, it's measurable.
How does climate change actually do that? Make more pollen or make the season last longer?
It's mainly about two things: temperature and CO2. Warmer global temperatures mean spring starts earlier, fall lasts longer. Plants respond to these temperature cues.
So they start pollinating earlier and stop later.
Exactly. They have a longer window to release pollen. Plus, higher levels of carbon dioxide in the atmosphere, from burning fossil fuels, acts almost like a fertilizer for a lot of these allergenic plants. It helps them grow bigger and produce more pollen per plant.
So if your hay fever seems to kick in sooner each spring and stick around longer and feels worse, it's not just you.
Not just you. Recent studies, summarized in the research, confirm it. Climate change is increasing both the prevalence, more people affected, and the severity of allergic diseases. Higher pollen counts, longer seasons.
You also mentioned plants thriving. Does climate change actually let allergenic plants spread to new areas?
Yes, that's another factor. As temperatures warm up, places that used to be too cold for certain plants, like ragweed, for instance, are becoming suitable habitats.
So they migrate.
They can, yeah. They establish themselves in new regions, exposing people who maybe never encountered that specific pollen before, leading to new sensitivities.
And the science on this connection is solid.
It is. Climate models, ecological studies, they all back this up. They show the direct link between warmer temps, higher CO2, and increased plant growth and pollen output. It matches what we're seeing in pollen counts.
There was also something in the Q&A about tiny particles making allergies worse, something called nanosilica.
Yeah, that was an interesting extra layer mentioned in the research. Exposure to certain tiny airborne particles, like nanosilica from various environmental sources, seems to make pollen allergies worse for some people.
Wow.
The thinking is these particles might damage cells in your nasal passages or increase inflammation, essentially making your immune system react even more strongly when pollen comes along.
Adds another reason why overall air quality matters so much. Okay, given this is happening, what can public health systems even do about it?
Consumers' research points to a few key areas. Better pollen monitoring and forecasting is one. Raising public awareness about this climate health link. Investing in research for better allergy treatments. And, crucially, tackling air pollution itself, since pollutants can aggravate allergic reactions.
And the bigger picture, globally.
Well, it means a growing burden on healthcare systems everywhere. More people needing diagnosis, treatment, ongoing management. It strains resources, especially in places feeling the climate impacts most acutely.
So this deep dive really shows climate change isn't some abstract thing. It's having direct personal health effects right now, like making your allergies worse each year.
It's a very clear example of how global environmental health connects directly to our individual health.
Okay, let's change tack completely now. Moving from the air to what we drink. And this next headline from Consumers 360, sourced from Rolling Out, is definitely provocative. Fruit juice is secretly worse for you than actual soda. Wow. That makes you stop and think.
It does, doesn't it? And the Consumers Research Q&A digs into why that headline has some truth to it. The main point. Fruit juice often has just as much sugar, sometimes even more, than the same amount of soda.
Wait, more sugar than soda? How is that possible? Isn't juice supposed to be the healthy choice?
It definitely goes against the common perception, yeah. But the research mentions looking at the numbers like an 8-ounce glass of certain juices, say cranberry cocktail, might have around 33 grams of sugar.
And soda.
A typical soda might have closer to 26 grams in the same amount. Because the sugar content is so high, juice can cause those same rapid blood sugar spikes and potentially carry similar metabolic risks as sugary drinks.
So just looking at the sugar load, a glass of juice and a can of soda could be surprisingly similar.
From that specific angle, yeah, they can be. Despite juice having this health halo, right? And this is where the comparison between juice and whole fruit becomes really important, as the research highlights.
The fiber difference.
Exactly. Whole fruits are way better because they have all that natural fiber, which gets mostly stripped out when you make juice.
And the fiber does what again?
A few key things. It slows down how your body absorbs the natural sugars, so you don't get that sharp spike. It makes you feel fuller. It often holds onto more vitamins and antioxidants that get lost in processing. And it's good for your gut health, acts as a prebiotic. Juice gives you the sugar rush, but takes away most of those benefits.
You get concentrated sugar without the good stuff that makes eating an actual orange beneficial.
Pretty much, yeah. That's why you see dietary guidelines shifting towards recommending whole fruits over juice, trying to define free sugars in juice more clearly, and suggesting limits on how much juice people drink.
The research mentions some kind of gadget, too, for sugar.
Oh, right. Just a quick tech note. There was mention of a low-cost digital refractometer using camera tech, basically a tool that could let people easily measure the sugar content in juice themselves.
That's kind of cool, putting the info in your hands.
Yeah.
What about the public health side, like soda taxes?
Yeah, that raises interesting policy questions. These sugary drink taxes are meant to reduce consumption, right? But they often exempt 100% fruit juice, even though it's packed with natural sugar.
Even if it has as much sugar as the tax drinks.
Sometimes, yeah. So it makes you wonder how effective those policies really are at tackling obesity if a big source of sugar like juice gets a pass.
This is like a bit of a disconnect. Okay, so key takeaway for you, the listener. Maybe rethink that glass of juice. It's not the same as eating fruit, and the sugar content means it's not automatically the healthy choice compared to soda.
It definitely calls for a more critical look at what we're drinking.
All right, let's wrap up this deep dive with our final topic. And this one connects something really basic in your diet to a huge, very modern environmental issue. The last headline from Consumers.App via the Seattle Times: need a different reason to eat more fiber. How about microplastics? Oh, that's a headline.
It definitely grabs your attention, and it points to some really interesting emerging research discussed in the Consumers Research Q&A. The idea is that eating more dietary fiber might actually help reduce how much microplastic your body absorbs.
How on earth would fiber do that? Does it, trap the plastic bits?
That's part of the thinking.
Yep.
One idea is that fiber helps keep your gut lining healthy and strong. A more robust intestinal barrier might be better at physically blocking microplastics from crossing over into your bloodstream. The research specifically mentioned one finding. People eating around 30 grams of fiber a day seem to absorb significantly fewer microplastics compared to those eating less.
So, stronger gut wall equals less plastic getting through.
That seems to be one potential mechanism. Another way fiber might help, also mentioned in the Q&A, is just by keeping things moving.
Promoting regularity.
Exactly. Good gut motility, regular bowel movements. Fiber helps move waste through your system efficiently, so the thinking is it might help push microplastics out before they have much chance to be absorbed lower down.
Wow, that's actually a pretty powerful idea. That simple dietary fiber could offer some defense against this pervasive pollutant. Where are all these plastics even coming from?
Oh, they're everywhere now, unfortunately. Big sources are things like synthetic clothes shedding tiny fibers when washed, think fleece jackets. Also breakdown of plastic packaging, microbeads, and some old cosmetics, industrial runoff.
And they get into
waterways, soil, the air. They build up in ecosystems, get into the food chain. The research mentioned the Nile River as an example, finding high levels of contamination, especially plastic fibers, linked back to city waste.
And they travel far, right? Not just staying local.
No, that's one of the really concerning parts. Studies show these tiny fibers especially can travel huge distances in the atmosphere. They've been found in really remote places, even way up in the stratosphere.
That's pretty unsettling, thinking they're just floating around everywhere. And if they do get inside us, what are the worries, health-wise?
Well, Consumers Research notes they've been found in human tissues. Lungs, intestines. The concerns being studied include potential breathing issues if inhaled, maybe digestive problems. Some early research is looking at possible links to inflammation or even nodules in lung tissue. It's definitely an active research area, but just finding them there is worrying.
Can scientists even see or measure these things easily? They're microscopic, right?
The Q&A mentioned briefly that there are advancements, like using special laser spectroscopy techniques to get better at identifying and imaging them. That tech is crucial for tracking pollution and understanding where they end up.
So for you, the listener, here's maybe a surprising but pretty compelling new reason to up your fiber intake. It connects your personal food choices directly to this huge environmental issue of microplastics and suggests your diet might actually play a role in protecting your body.
It definitely puts a very modern spin on the age-old advice to eat more fiber.
We've really covered a lot of ground today in this deep dive, haven't we? From busting pet allergy myths and understanding crucial food labels,
to seeing how climate change is hitting our seasonal allergies, questioning the health halo of fruit juice,
and even learning how fiber might help fight microplastic absorption. Quite a range.
It really shows how connected everything is, our health, our environment, the things we buy and eat. And all these insights came from that Consumers.App Consumers 360 commentary from June 8th, 2025.
Well, thanks so much for tuning in and joining us for this deep dive. We really hope it gave you some useful takeaways, maybe challenged an assumption or two.
You can find loads more insights like this over at Consumers.App.
And please do like, share, and subscribe to Consumers 360.
And one last thought to leave you with. Considering how much our environment and what we consume impacts us in these surprising, hidden ways, allergens hitching rides on clothes, fiber maybe battling plastic, what other really important unseen connections might we be missing in our everyday lives?